Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to be looking at how we can use Excel to do a simple Taylor series computation. And we'll be specifically doing this for the series for the exponential of x, or e to the x. And if you'll recall, this series is 1 plus x over 1 factorial plus x squared over 2 factorial, etc. Basically x to the k power over k factorial, the sum of infinitely many terms. So let's look at doing this in Excel. So if we look at this, then I start with a blank worksheet, and I am going to fill these various cells with all sorts of information that's going to do calculations. If you are not familiar with Excel, I'm going to refer you back to look at some other video lessons. You can look at some of mine, but there are many available online. I'm just going to be showing you a few basic skills. I'll take some time with those on the ones that are relevant for this project. But this is not going to really, I may say some things that might confuse you if you're truly a new Excel user. But so I'm going to start by saying that I'm going to put in a value of x, and I'm going to put in, it doesn't really matter, 0.634, okay? And I can reformat this. I mean, personally, I think it looks better if you write them so that they're kind of squished up together. They look like a full statement, but that's just totally my choice. You could do something like to let people know that this is where they're going to put in their information. I could block it out, I could color it yellow, something like that. But that's going to be where the user enters their value of x. And now then, I want to start my series. And so my counter for my series was k. So k is equal to 0, 1, 2, and I need infinitely many terms. First of all, I'm going to center this just because I find it visually more appealing. And 0, 1, 2, I really don't want to have to keep counting those, so I'm going to take advantage of Excel's autofill. Once you establish a pattern, you can highlight a series of cells and click down in the bottom corner, and if you drag this, you can do as many terms as you want. Okay, I'm doing 25. So I did 25 terms there, and notice how it auto-populated that. Sometimes it gets it wrong. You can actually click on this box here and you'll see some other options. Now, part of this exponential function is that it requires us to use factorial. So k factorial, and again, I'm going to want to center this. K factorial for 0 is by definition equal to 1. And for these others, it's always this number, 1, times the factorial for the number just one smaller. So I get 1 for 1. If I copy this, I use Control C and now I'm using Control V. I can copy those down and you can just check and make sure it's doing the formula the way you expected. Now I want to get the individual term. The individual term is x to the k power over k factorial. Now, okay, again, that's not visually appealing. It doesn't look like algebra to me, so I'm going to highlight this k that's supposed to be a power. I'll come up to font, and I'm going to use superscript. And so now it looks like proper algebra. And I can do this a couple of different ways. One thing I can do is, I'd like it to look like algebra, so I can come up here in this cell where I've entered the value for x. I can either refer to this as B1 every time, or I can very cleverly come in here and name it x, because x is what I've called it in my formula. And so what that allows me to do is I can say it's equal to x, and it now knows exactly to go to cell B1, raise that to the k power, so a caret to the k power, divided by k factorial. And I'm going to do this, we'll do it to Let's do 4 digits. Okay. I'm going to center this, Control C, and I'm just going to copy that all the way down. And you'll notice it very quickly goes down to essentially 0 because we're dividing by some very large numbers. Now, e to the x is equal to the sum of these. Okay? Again, I'm going to make it look more like algebra by highlighting that and using superscript. Okay, so that's going to be the sum. And so the first time, it just simply is the first term. But after this, it's this plus this term over here. Okay? And if I copy this, let's just do it down to 1, and look at this, it's doing the one above and the one next to it. That's called using relative references. And I can continue that, since I'm happy with the way that formula worked, all the way down. And we see that very quickly, by the 6th term, it's converged to a value of 1.8851. Now let's compare this to the actual value. So I'm going to calculate the error here. Okay, and the error in this case is going to be my sum minus the actual e to the x. And I'm going to stretch this over to make it look like it fits the space a little better. Okay, and so the sum is the number that I've got in column D, and e to the x is the exponential, is how you do this in Excel, of x. And the error you see is, well, it's off by 0.8851 initially. But as I go through all these terms, I get down to where 2 4 sig figs, the error is 0 after only a few terms. It only took 5 terms, and then the 6th one, I had the answer to 5 sig figs, exactly the same as the exponential of x. Now the nice thing about setting it up like this is I can come in here and I can change my value of x. So let's say I changed to negative 1.32. Okay? It immediately goes through and does the calculations, and you see that this time it took until the 8th term before we got an error of 0. As we increase this, maybe I wanted to do 20.1. Okay? Well, that's going to take an awful lot more terms, okay, because I'm not close to 0 at all. So here I have run into a problem where I have exceeded Excel's capability of the sig figs digits. Okay, I've used more than it can do. Okay, so let's bring this back. Let's do 5.3. It'll like that one better. Okay, now we got down to 19 terms. The 20th term, I'm down to an error of 0. So the further away I get from 0, because this was a Maclaurin series, it takes more terms. Okay. I accidentally right-clicked, ignore what just showed up there. So it takes more terms the further away I get from 0. At some point, I'm going to exceed Excel's capability of keeping track of digits, okay, which is why I had it so that it never went to 0 on some terms, okay. But anyway, so this is our little file. We were using relative references, so when I drag and drop, it's going to always remember how many cells away. Did I hop to the left or did I hop above? And that's using relative references. And we covered how to name a cell in this little lesson. Okay? In our next lesson, we're going to be looking at how we can do this same problem using Visual Basic within Excel. Thank you very much.